Assalamualaikum warahmatullahi wabarakatuh. My name is Shasha Shafiah binti Khairuddin. I'm part 1 student of Group 12 from Faculty of Applied Science at UiTM Tapah. In this video, I will explain about calculation of composition of compound, empirical and molecular formula. Okay, first, I will explain about percent composition. Okay, the percentage composition of an element in a compound is the mass percentage of the element present in the compound. Okay, here is formula of percent composition. Okay, percent composition of an element in a compound equal to n multiple with molar mass of element, and then we divide with molar mass of compound. Then we multiply with 100. Okay, n is the number of moles of the element in 1 mole of the compound. Okay, here is an example of a methanol. First, we need to calculate the percent composition of a carbon. Okay, the number of moles of carbon in a methanol is 3. So 3 we multiply with molar mass of carbon, which is 12, and then we divide with molar mass of methanol, which is 60, and then we multiply with 100. So we get 60% of carbon. Okay, next is hydrogen. The number of moles of hydrogen in the methanol is 8. So 8 we multiply with 1, which is hydrogen's molar mass, and then we divide with molar mass of methanol, which is 60, and then multiply with 100. So we get 13.33%. And the last one is oxygen. The number of moles of oxygen in the methanol is 1. So 1 we multiply with 16, which is molar mass of oxygen, and then we divide with molar mass of methanol, which is 60, and then we multiply with 100. So we get 26.67% of oxygen. So the total percentage of composition of a methanol must be 100%. Okay, next I will explain about empirical formula. Okay, empirical formula is the simplest formula for a compound is directly related to its percent composition. Okay, it gives the simplest ratio of atoms in a molecule. Empirical formula also cannot get the exact molecular mass. Okay, here I will explain about steps for determining a compound's empirical formula. Okay, first we need to calculate the mass of each element in grams. Okay, second, we calculate the number of moles of each atom. Okay, third, divide the number of moles of each atom with the smallest number of moles found in the previous step. Okay, fourth, convert the numbers as simple as multiplying 1 by the smallest numbers. The simplest formula utilizes these whole numbers as a subscript. Okay, this is the last topic in this video. I will explain about molecular formula. Okay, molecular formula is describe the exact number and type of atoms present in a single molecule of a compound. Okay, molecular formula can get the exact molecular mass. Okay, the formula showing the type of atoms and number of each atom connected in the molecule. Okay, here is the steps to calculate molecular formula of all elements. Okay, first we need to calculate the empirical formula from percentage composition. Second, we calculate the empirical formula mass by adding up the molar atomic masses of all atoms constituting the formula. Next, we determine the molar mass of the given compound, and we also determine the value of n. It is done by dividing the molar mass of the compound by the empirical formula mass of the compound we calculate in step 2. Okay, the last one, we need to multiply all the subscript in the empirical formula by the whole number found in the step 4. So the result is the molecular formula. Okay, here is an example that I prepared. A sample was analyzed and found to contain 40% of carbon, 6.71% of hydrogen, and 53.29% of oxygen. If the molecular weight of the compound is 180.60 grams per mole, what are the empirical and molecular formula of the compound? Okay, first we must determine the empirical formula for this compound. Okay, for elements, I will put C here, H here, and O. This is for carbon, this is for hydrogen, and this is for oxygen. Okay, for mass, the percent composition that are given in this question, there are also a mass for this atom. Okay, For carbon, the mass is 40. For hydrogen, 6.71. For oxygen, 53.29. Okay, next, we must calculate the mole. Okay, to calculate the mole, we must divide the mass that are given with molar mass of each atom. Okay, for carbon, 40, we divide it with molar mass of carbon, which is 12. So we get 3.33. For hydrogen, 6.71 divided with molar mass of hydrogen, which is 1. So we get 6.71. For oxygen, 53.29 divided with molar mass of oxygen, which is 16. So we get 3.33. Okay, the last step to determine the empirical formula for this compound is we must do the simplest ratio. To calculate the simplest ratio, we must divide the mole of each atom with the smallest mole among all of these mole. Okay, so here the smallest mole is 3.33. So for carbon, 3.33 divided with 3.33. So we get 1. For hydrogen, 6.71 divided with 3.33. So we get 2. For oxygen, 3.33 divided with 3.33. So we get 1. So the empirical formula for this compound is CH2O. Okay, now we must determine the molecular formula of the compound. Okay, the first step to determine the molecular formula of the compound is calculate the empirical formula. So we have done that part. Okay, second, we must calculate the empirical formula mass. Okay, to calculate the formula empirical mass, we must multiply 1 with molar mass of carbon, which is 12, plus 2 multiplied with molar mass of hydrogen, which is 1, plus molar mass of oxygen, which is 16. So we get 30. Okay, the next step, we must determine the value of N. Okay, the value of N, it is done by dividing the molar mass of the compound with the empirical formula mass of the compound that calculate in step 2. Okay, so it will be like this. N equal to molar mass of the compound, which is 180.60 divided with empirical formula mass. So we got 30. So the answer is 6. So the value of N is 6. Okay, the last step to determine the molecular formula for this compound is we must multiply all the subscripts in the empirical formula by the whole number found in the step 4, which is 6. So the empirical formula is CH2O. The N value is 6. So we must multiply 6 with all of the subscripts of this empirical formula. So it will be C6H2 multiplied with 6, we get 12, and O6. So this is the empirical formula for this compound.
Okay, that's all from me. Thank you.